Hello everyone. So in today's video I am going to take up all the past paper question and a specimen paper question based on mole concepts. Like I explained in my last video about the mole concept and how are we going to apply this to solve this stoichiometry problem. So let's start with the 2026 specimen paper. Now look at this question. The volume occupied by 2 moles of hydrogen gas at STP. As I told you in the last video, every question they will be asking about STP, so you don't have to take tension for STP, or if anything is given without STP, it's not there. So your question will be always mentioning at a standard temperature and pressure condition. Now we have to solve this question based on the data given here. Now they have given the moles of a gas which is 2 moles, and they're asking how much volume is occupied by this gas. So as we know the ratio, the 1 mole of any gas occupies the 22.4 liter. So in that ratio, the volume occupied by 2 mole will be 2 times of 22.4. So the answer will be 44.8 liter. So this is my answer C. Let's move to the next question. The ratio between the volumes occupied by 22 gram of carbon dioxide and 10 grams of hydrogen gas. Now here they are asking the ratio of these two gases and they have given the mass. So if I will say the ratios between two gases which is given, it's 22 gram and 10 gram. Comparing ratios, we have to convert into a mole to both of these. So if I will convert this into the mole, I have to divide by the molar mass of carbon dioxide, molar mass of hydrogen, which is 2, and you will cancel out, you will get the 0.5 is to 5 mole ratio. So if we'll see the mole ratio, 0.5 to 5, it is 10 times. So my mole ratio, what I am getting, it is 1:10. Again, the correct option is option C. Let's move to the next question. What is the mass of the carbon dioxide which has the same number of molecules in oxygen gas? Now here the comparing gases are the carbon dioxide and oxygen. What data they have given? They have given the mass of oxygen gas and they are asking the mass of carbon dioxide gas which will have the same number of molecules. So if the molecules are same, that means they are having the same moles. So what we can do, we can calculate the moles of oxygen gas first. Now how will you calculate the moles of oxygen? As we have this formula, the moles will be equal to the given mass by the RMM of oxygen gas, which is 3.2 divided by 32. So you will get 1 by 10, which is 0.1 mole. So oxygen present is here 0.1 mole. So that means if the carbon dioxide has to occupy the same molecule, the moles of carbon dioxide must be 0.1 mole. So we got the moles here, but the question they are asking the mass of the carbon dioxide. So what we can do now, we can convert this moles of carbon dioxide to the mass. Now how do we convert? Again we are going to apply the formula, which is moles is equal to the given mass upon the RMM of carbon dioxide. Now we have to calculate the given mass, which is W. The moles we calculated is 0.1. RMM of carbon dioxide, if you calculate, you will get 44. So the answer you will get is 4.4 gram. So every question you have to see what the quantity they have given, whether it is mole, mass or volume or number, what you can compare with them, each and every quantity based on their moles. So we can convert into the moles and we can compare, and then we can get answer what the unit they are asking. So what I have done here, I have converted the oxygen, the mass, converted into the moles, and then as they have given, is it equal to the carbon dioxide? So once I know carbon dioxide moles, I have converted this into the grams of the carbon dioxide. Okay, let's move to the next question. Now this question is a 3-marker question. which is very common in ISC board examination, so you have to understand it very well. Now here the reaction is given where ammonium dichromate is heated and it produces the three compounds which is already given in your question, and it will be balanced equation. You don't need to worry about the balancing part. Now let's look at the question, what the values they have given, what quantities, and what you have to calculate. So they have given the mass of ammonium dichromate, and then they are asking the number of moles of ammonium dichromate that undergoes. Now this is a very direct question. They are asking for same compound. So ammonium dichromate, the mass is given 126 gram, and for same compound they are asking the moles. So now we know the formula again. We will divide this by the molar mass of ammonium dichromate, and ammonium dichromate molar mass is, when you calculate, you can calculate easily as the atomic weights are given. It will come 252 grams and you will get 0.5 moles. So my first answer is 0.5 moles of ammonium dichromate is there. Second question, they are asking the chromic oxide. Now chromic oxide is my product. Now if they have given for the ammonium dichromate and they are asking for chromic oxide, you have to see the balanced equation mole ratio. So if I will look at the balanced equation mole ratio, 1 mole of ammonium dichromate produces 1 mole of chromic oxide. So if I will write here ammonium dichromate ratio to the chromic oxide in my balanced equation, it is 1 mole to 1 mole. But based on the grams given of ammonium dichromate, it's 126. So what I got in the previous answer, that is 0.5 moles. So in my question, the number of moles present is 0.5 mole. 1 mole, what is there? That is the standard ratio when the equation is balanced. So 0.45 moles will also, what will be produced? So we can say 1 mole produces 1 mole of this. So 0.5 mole will also produce 0.5 mole of chromic oxide. Now the question is they are asking in the mass. So I can convert this 0.5 moles of chromic oxide to mass of the chromic oxide. We can apply the simple formula. The moles is equal to given weight by RMM of chromic oxide. We can calculate the RMM and we can find out the value. So W will be equal to 0.5, and when we'll calculate the chromic oxide mass, it is 152 gram, and then we can calculate. You can calculate it easily in the exam. The calculations are not very hard. You will get the 76 gram of chromic oxide is formed. So this is B part is done. Now let's look at the third part, volume of nitrogen gas evolved. Now again we have to go back to my balanced equation. Now in the balanced equation, the relationship with ammonium dichromate to the nitrogen gas, it is again 1:1 mole. So again I'll write down here ammonium dichromate to nitrogen gas, the ratio is 1 mole to 1 mole. In equation, what the values we have calculated, we got 0.5 mole. So that will also produce same mole, because the ratio is 1 mole to 1 mole, and so same moles of reactant is producing same moles, so and nitrogen gas. So ammonium dichromate will also be producing the same moles of nitrogen gas. But here you have to calculate the volume of the gas. So we got to know the moles of the gas. So then we can apply the formula volume by the molar volume, which is volume we have to calculate, which is 0.5 multiplied by the standard volume is 22.4 liter, and you can multiply easily, and can get the answer, which is 11.2 liter. So you can see these all questions, every part of this question is related to each other, and it starts with the moles of ammonium dichromate because this is a thermal decomposition of ammonium dichromate, and the question they are asking related to the products form, the volume of the products and mass of the product. So whatever given in the moles in the first part which we have calculated, we will take that ratio and find out all the answers with respect to that 0.5 moles. Now let's move to the next 2025 specimen paper. This is an MCQ question. Which of the following would weigh the least? Now we have to find out the mass of all the substance and which weigh the least. So you can see here 2 gram atom of oxygen. Now 2 gram atom is the term which means the 2 moles of oxygen atom. Now 1 mole of sodium, 22.4 liter of carbon dioxide, and 6.023 into 10 raised to the power 23 atoms of carbon. So every unit, as they have given in moles and liter and number, we can convert into the moles and we can calculate the mass of that. So 2 moles of oxygen atom, as you can see the masses are given here. 2 moles of oxygen atom means the mass will be 2 multiplied by 16, which is 32 gram. 1 mole of sodium is already given, the 23, 1 into 23, which is equal to 23 gram. Carbon dioxide 22.4 liter means how much moles are there? So 22.4 divided by 22.4, which is 1 mole, and you can calculate the 1 mole mass of the carbon dioxide, which is 44 gram. Similarly, 6.023 into 10 raised to the power 23, which is an Avogadro number. So that means we have 1 mole of carbon. 1 mole of carbon means the mass is 12 gram. So we can see now which is the least. So we can say the option D, as it is corresponds to 1 mole of carbon, which weigh the least. I hope you understood. You can pause the video, you can understand what I am doing it, and you can practice again. Let's go to another question. This is another MCQ. Ratio between the volume occupied by 4.4 gram of carbon dioxide and 2 grams of hydrogen gas. So now here they are asking a ratio. Whenever they ask this ratio, the first thing you have to solve it, and you have to think, no, I have to compare the data given in the question here. 4.4 gram of carbon dioxide and 2 gram of hydrogen gas. And they are asking the volume, the ratio of volumes occupied by 4.4 gram of carbon dioxide. So if we'll convert this grams into moles, so we can find out the volume also, because moles is a quantity which relates to the mass volume as we discussed in my last video. So I can convert this gram into moles by dividing by its molar mass and hydrogen also, and I will get here 0.1 mole, and this I will get 1 mole. So you will see what is the ratio of 0.21. It is 10 times. So my ratio to this is 1:10, which is the option C. So I hope you are understanding how to solve. Go step by step initially. Once you become very proficient in the concepts, you can do very fast in the. Okay, now let's move to the next question. Okay. Yeah, so we can see this question. This is a 2-mark question where there is a reaction given, and based on the reaction, they are asking about the volume and mass. So first look at the reaction. Reaction is given about the thermal decomposition of calcium nitrate. We can see here. And then they have given the mass of calcium nitrate. So we should look at the question first, which is the first part. Volume of nitrogen dioxide gas. So what you have to do, first thing, you write down the mass, the substance which mass is given, which is the reactant here, calcium nitrate. to the nitrogen dioxide. Now what is the mole ratio in the balanced equation for this? So I can see here 2 moles of calcium nitrate produces 4 moles of nitrogen dioxide, but in the question they have given as the mass of that, and they are asking the volume of nitrogen dioxide. So how I can find it about? Now best way to convert this gram into moles of calcium nitrate and this calcium nitrate moles to find out the moles of NO2, and this moles of NO2 you can find out the volume of NO2, which is the basic root path of this calculation. So first thing, to calculate the moles of calcium nitrate, we need to calculate the RMM of calcium nitrate. All the masses will be given to you. You don't need to memorize any masses of any element. So you can calculate calcium is 40 plus 2 times 14 plus 6 times 16. You will get 164, right? So you can find it 164 gram is the mass of calcium nitrate. Now we can calculate the moles of calcium nitrate. Again the formula we are going to apply, which is the given mass is 8.2 upon molar mass, and you cancel it, solve it, and you will get 0.05 moles of calcium nitrate. Now I got the one part answer where I know, okay, the calcium nitrate is 0.05 mole. Again, now I can take the ratio of calcium nitrate to nitrogen dioxide, which is 2:4 moles. So I can write down here calcium nitrate is to nitrogen dioxide. The mole ratio is 2:4 in the balanced equation. But what I calculated with the mass given, it is coming of 0.05 moles. So what will be the moles? You can do cross multiply, crisscross method. So X will be equal to 4 times 0.05 upon 2. You cancel, you will get 0.10 moles of nitrogen dioxide. So I got the moles of nitrogen dioxide, but the question they are asking about the volume of nitrogen. So how do you convert the moles into the volume? Now come to the formula again. Volume of nitrogen dioxide. How do? We know the formula, the moles is equal to given volume by molar volume. So we can say the moles is 0.10. Volume we have to calculate. Molar volume, you know, 2.4 liter. So we can find out the volume, it is 0.10 into 22.4, which will give you an answer 2.24 liter. So my first answer for the volume of nitrogen dioxide is 2.24 liter of nitrogen dioxide gas is obtained. Now let's move to the next part, the mass of calcium oxide form. Again we have to go back to the mole ratio. So if you see the mole ratio here, 2 moles of calcium nitrate produces 2 moles of calcium oxide. So let's use this data to calculate here the B part. Calcium nitrate is to calcium oxide. In my balanced equation, 2 mole of this produces 2 mole. But how much moles are there for 8.2 gram? This is 0.05. So 0.05 mole will be equal to how many moles of calcium oxide? We can do again crisscross method. So X will be equal to 2 into 0.05 upon 2. So we will get 0.05 moles. So we got to know the moles of calcium oxide. Now the next step is very simple. We can convert this moles of calcium oxide to the mass. So formula will be again the same thing we are using, W by RMM of calcium oxide, which is equal to 0.05 multiplied by the RMM is equal to W. Now if I will calculate the RMM of calcium oxide, it is 40 plus 16, which is 56. So 0.05 into 56, which will give you the value 2.8 gram. So we got the answer as the mass of calcium oxide produced is 2.8 gram. So I hope you understood. Only thing, students, keep this in your mind that whatever data they are giving it, whatever mole, whatever volume, everything, if you convert into the moles, you can relate to any quantity what they are given. So keep the route map in your mind very clear so that it will be easy for you to solve the problems. Now let's solve the question which came in 2024. Again, you see there is a reaction given and they are asking some question based on the reaction. Now let's read the question now. The first part, they are asking the mass of 5 moles of calcium carbonate, and the calcium carbonate reaction is given is reacting with an HCl and forming the calcium chloride, water and CO2. Now this is a very direct question where they are asking the mass of 5 moles calcium carbonate and RMM of this is given. So this is very simple. We can apply directly the formula which is given. Mole is equal to the mass which we have to calculate, the molar mass of calcium carbonate. So I will get W is equal to 5 times 100. So answer will be 500 grams. So this answer we got it 500 gram, and each question is of 1 mark. So this question is of 3 mark. Actually ICSE has a pattern of these type of question. Whenever they give a mole concept question applied to stoichiometry, they will give any reaction and they will ask based on 2 or 3 parts for them. So usually it comes for 2 or 3 marks. So if you are practicing, you can practice as many questions from the past paper and the practice question similar like this. Now second part, let's look at the second part. How many moles of HCl will react with 5 mole of calcium carbonate? Now it is comparing the calcium carbonate to HCl. So we have to refer to the balanced equation where I can see 1 mole of calcium carbonate, it is producing it is reacting with the 2 moles of HCl. So 1 mole of calcium carbonate needs 2 moles of HCl. So how many moles of HCl will react with 5 mole? So it's very simple. It's X mole. You can do cross multiply. So X will be equal to 5 times 2, which is 10 moles of HCl is required to react with 5 moles of calcium carbonate. So this answer is 10 moles. Now let's move to the last part. What is the volume of carbon dioxide liberated at the same time? So again I can take the same ratio, calcium carbonate ratio to the carbon dioxide. So it's my standard equation. The mole is 1 mole of this produces 1 mole of carbon dioxide. So we can see here 1 mole of calcium carbonate produces 1 mole, and now what the question we have 5 moles present, so it will produce 5 mole of carbon dioxide, but we have to calculate the volume. So how can we calculate the volume of the carbon dioxide? The same formula you can apply. 5 moles multiplied by the molar volume, you will get the 112 liter. So this answer is 112 liter of carbon dioxide will be produced. Now let's move to another specimen paper question. This is an MCQ question. Now for MCQs always sometimes they are tricky and they are not involve so much of calculation, so you have to be very smart in solving. Now let's look at this question now. The atomic mass of sulfur, oxygen and helium is given. Now you have to calculate which of the following statement regarding the number of atoms in 32 gram, 16 gram is correct. So I have 3 elements, sulfur, oxygen and helium. The mass is 32, 16 and 4. Now sulfur mass is 32, that means it represents 1 mole. Oxygen represents 1 mole and this represent 1 mole. That means all are 1 mole is given. Now let's see and compare in the moles. 16 P statement says 16 gram of oxygen contain 4 times the number of 4 gram of helium. Now 16 grams of oxygen means they are comparing oxygen to the helium. Now 16 gram of oxygen means they are talking about 1 mole contains 4 times the number of atoms as in 4 gram of helium. Now 4 gram of helium, if you see, it is the same 1 mole. So and we know that 1 mole of any substance contain the same number of particles. So this statement is wrong. Now let's look at the second statement. 16 gram of oxygen contain half the number of atoms as 32 gram of sulfur. 16 gram of oxygen, again it's a 1 mole, and 32 gram is again it's a 1 mole. So doesn't matter which substance is that, 1 mole of any substance will contain the same number of atoms. So this statement is also wrong. So my option is D here for the correct answer. Let's go to another question. This is a 1 mark question again. Calculate the number of moles in 22 gram of carbon dioxide. This is a direct formula based question. So you have to divide the given mass by RMM of carbon dioxide, which is 22 upon 44. You cancel, you will get 0.5 mole of carbon dioxide. This question is again, see, it is repeated in the 2020 specimen paper. Is given 5. So it's the same question. I am not solving that because it's the same we did earlier. So you can see the pattern of the question and you can understand how you have to calculate the volume or mass or number with respect to the mole ratio. Now let's solve the question which came in 2020. So this is a 1 more question. So you can see the first part, the number of moles in 11 gram of nitrogen gas. Now here the what student do, the common mistake, the nitrogen gas, the formula of nitrogen gas is N2. So if we have to calculate the moles of nitrogen gas, we need to have the mass of nitrogen gas upon the RMM of nitrogen gas. So we need to calculate the molar mass of the nitrogen gas. So it is N2, RMM of N2 will be 2 times 14, which is 28 grams, and we'll apply to the formula 11 divided by 28, and you will divide, you will get answer 0.39. So my option is this. Now what student get confused here in this question, what they do, instead of taking the nitrogen formula of nitrogen gas as N2, they take only nitrogen, which is 14. So what they do, they divide 11 by 14 and then they get the answer which is different, which is not given in the options here. So it's very clear here what you have to be very careful, that if it's a gas, it's a molecule. If it's nitrogen, hydrogen, any gas, so the formula you have to take the molecular formula, which is N2. So I hope it's clear now, the confusing part here. Come, let's do the second part question now. Calculate the number of moles present in 160 gram of NaOH. So to calculate the number of moles in 160 gram, we need to know the RMM of NaOH, which is NaOH. So I can say here the masses will be given 23 plus 16 plus 1. You will get 40 gram. Now my calculation is a direct step where I can find out the moles of NaOH will be equal to the mass of NaOH divided by the RMM of NaOH, so which is 160 by 40. You cancel, you will get answer 4 moles. So the answer mine here is the 4 moles of NaOH present in 160 gram of NaOH. Let's move to the next question. This question is appeared in 2019. Now look at this question. Question number 1. The number of moles in 12 gram of oxygen is. It's the similar type which I discussed just now. Number of moles in 12 gram of oxygen atom. So what we are going to do? The moles will be equal to the mass of oxygen upon the RMM of oxygen gas. The mass of oxygen is given 12. RMM of oxygen gas is 2 times 16, which is oxygen gas formula is O2. So we will get 12 divided by 32. I will get here 0.0375 moles. So this is a 1 marker question. It's very straight away, direct. Apply to the moles formula and you will get an answer. Let's look at the second question. The weight of 10, it is 10 raised to the power 22, not 1022. 10 raised to the power 22 atoms of carbon. So we have to calculate the moles in 10 raised to the power 22 carbon, and then we can find out the weight of the carbon, or we can do it in one step. So let's do both the ways. So first what we will do, we will convert the 10 raised to the power 22 atoms to the moles of carbon, and from the moles we can find out the weight of carbon. So this is my route map which I am following for stepwise if I am going to do it. So 10 raised to the power atoms, 22 atoms for carbon will be equal to the how many moles? So moles will be equal to 10 raised to the power 22 upon 6.022, 10 raised to the power 23. As they have given the Avogadro number here, so we are not going to take this Avogadro number. This is also a very important point. If they have given the Avogadro number, take that Avogadro number, because usually we take 6.022 or 6.023, but if they have given 6, it will make your calculation more easier. So we can see here 10 raised to the power 23. So you can convert, this is the moles of carbon present in the 10 raised to the power 22 atoms of carbon. Okay, now I have to convert this moles into the mass. So again I am going to use the formula. My moles is equal to the weight of the carbon, which is I have to calculate, divided by the RMM of carbon. So if I will see, I have already calculated the moles, which is 10 raised to the power 22, 6 into 10 raised to the power 23. The weight of carbon we need to calculate. RMM of carbon is 12. So my weight of carbon will be equal to 12 times 10 raised to the power 22 upon 6 into 10 raised to the power 23. You will cancel, you will get 0.2 gram. So this is the way you can do it, where in 2 steps you will convert into moles and moles into weight. The other way is that I told you in my previous video that we can do in one step, where we will find out what ratio they are giving. So they are comparing the weight and the number of molecules. So if the number of moles formula is the weight upon the RAM of carbon, which is also equal to the number of atoms present and the Avogadro number. So I can use this formula and I can get my answer in one step. So weight of the carbon is given 12. RAM of carbon is weight of carbon. The weight of carbon we need to calculate. So weight upon RAM, number of atom is given 10 raised to the power 20 and 6 into 10 raised to the power 23. So W will become 10 raised to the power 22 into 12 upon 6 into 10 raised to the power 23. You will get 0.2 gram. So this is the one which I have done in one step by equating the weight and the number formula together, and the previous step I have calculated into the moles and moles I have converted. So I hope you understood both the ways. Again I am repeating, whatever way is convenient for you, you follow that, and you don't need to do both the ways in exam. Any one way is fine, whatever you are very confident enough. Now let's solve the 2018 question. Again, this is a reaction based question. You can see a reaction is given where aluminum chloride reacts with water from aluminum hydroxide and methane is evolved. So the first question they are asking that what mass of aluminum hydroxide is formed from 12 gram of aluminum carbide. Now for every question, as I am telling you again and again, you have to see what you have to find out and what is given. Now here they have given the mass of aluminum carbide. So I will write down this aluminum carbide and they are asking the mass of aluminum hydroxide. So what is the mole ratio present in the balanced equation? So I can see here 1 mole of aluminum carbide produces 4 moles of aluminum hydroxide. This is what I am taking the data from the balanced equation. But in the question they have given the 12 gram of aluminum carbide will produce how many grams of aluminum hydroxide. So I need to convert this mole into mass. So 1 mole of aluminum chloride, you can see they have given directly the mass, so you don't need to calculate the molar mass here. So it will form, I can say 144 gram of aluminum chloride produces. Now 4 moles also we can calculate the mass, as they have given mass for 1 mole of aluminum hydroxide is 78. So 4 into 78 gram of aluminum hydroxide. Now what I can do, if I know from the balanced equation 144 gram produces 4 into 78 gram. So 1 gram will produce how much? 4 into 78 upon 144 gram. And in the question it is mentioned to calculate for 12 grams. So 4 into 78 upon 144 into 12. Now you will solve this equation and you will get the answer. When you calculate this, 12, 3 and you will get, so 26 grams of aluminum hydroxide are formed. So I hope you are clear this. What I am doing it here, again the same thing. The mole I am converting into the mass because the question I have to calculate answer is the mass, and then I am comparing the mole ratio to the mass ratio in the balanced equation. Second part, you see the volume of methane at STP from 12 gram of aluminum carbide. Now if I will see the balanced equation here, we can see here the aluminum carbide ratio to the methane is 1 mole to 3 moles. So 1 mole of aluminum carbide produces 3 moles of methane. So 12 gram will produce how many liters of methane gas? So again what we have to do here, so if it is they are giving the grams, I have to convert this into mass. So 144 gram of aluminum carbide, it's producing 3 moles. 3 moles means, if I will say in the liters, 3 times 22.4, because 1 mole occupies 22.4 liters. So I can say that 144 gram of aluminum carbide produces 3 into 22.4 liter of methane. So 1 gram will produce how much? 3 into 22.4 upon 144, and 12 gram will produce 3 into 22.4 upon 144 into 12. So again, so you will get here, you can divide this 22.4 divided by 4, whatever answer you are getting it, this is 5.6 liter. So it will occupy 5.6 liter this gas. So I hope is it clear to you that the method which I am doing it, I am just comparing the ratios whatever it is given in the question and moles converting to that quantity. Now let's refer to this question. It came in 2017. It's a very direct question. Number of gram atoms in 4.6 gram of sodium, and I told you before gram atoms means moles of sodium we have to calculate. Now moles will be equal to the whatever the weight of sodium upon the atomic mass of the sodium, weight is given 4.6 and the mass of sodium is given 23. So we can substitute the values and we can get the direct answer. So it will become 0.2 gram atoms of sodium is present in 4.6 gram of sodium. Okay, now let's move to the question which came in 2016. Okay, let's read the question now first. How much calcium oxide is formed when 82 gram of calcium nitrate is heated, and find the volume of nitrogen dioxide evolved? So there are two parts of the question. It is of 2 marks. So calculating for any quantity of reactant which is used or volume of the product produced, we have to refer to the balanced equation. So you see the equation here. Now the first part of the question, they are asking the calcium oxide form to calcium nitrate. So what is the mole ratio for calcium oxide to calcium nitrate in the balanced equation? So you can see 2 mole of calcium nitrate produces 2 moles of calcium oxide. So they are asking in the question that 82 gram when it is heated, then how much grams of calcium oxide will be formed. So what we can do, we can convert this moles into mass, and then we can find out in 82 gram how much mass of calcium oxide will be formed. So how will you convert this moles into mass? So 2 into multiplied by RMM of calcium nitrate and 2 into multiply RMM of calcium oxide. So you can calculate the RMM, which will be 2 into 2 times of calcium nitrate, which is 40 plus this is 14 plus 3 times 16 times 2. That will be the mass of calcium nitrate. So you will get solve it. You will get 328 gram. Same way we can calculate for calcium oxide, which is 2 times of 40 plus 16, which is you will get 112 grams. So now in my stoichiometric ratio, in the equation says that 328 gram of calcium nitrate produces 112 gram of calcium oxide. So 82 gram of calcium nitrate will produce x gram. So you can find it out. X will be equal to the 112.328 multiplied by 82. You solve it, you will get answer 28 grams. So if you're getting answer is 27.9 grams, you can write close to the whole number 28 gram, or you can leave it 27.9 grams. So that both answers are accepted. So I hope it's clear to you. This is the first part. Now second part is the volume of nitrogen oxide evolved. Again we will refer to the reactant to the volume of the gas. So here the ratio will be compared between calcium nitrate and nitrogen dioxide. So if we'll see the stoichiometric ratio, 2 moles of this produces 4 moles of nitrogen dioxide. Now we have to calculate here volume of nitrogen dioxide gas, that means in liters. So what we can do here, 2 moles we can same thing, we can convert into mass, which we have done already in the first part, and 4 moles means convert into the volume multiplied by the molar volume, which will give the 4 into 22.4 liters of volume of gas evolved when 328 gram of calcium nitrate is used. Now again same thing, we are going to write it like 328 gram of calcium nitrate produces 4 into 22.4 liter of NO2 gas. So 82 gram of calcium nitrate will produce 4 into 22.4 upon 328 into 82 gram. You will calculate, you will get 22.4 liter of nitrogen dioxide. This is your answer. One thing you have to remember here, or you can while solving the question, no need to get multiply here and get one answer, because when we are finding the x, you can cancel is easily when the numbers are small, because you will multiply 4 into 22.4, you will get a bigger answer, and again you have to divide by a bigger number to a bigger number, right? So it will become little difficult and it will time consuming during the examination. So let it be there. Final step only, you multiply, divide, whatever the operations you are using it. So this is the 2-mark question. Each part is 1 mark. So we got the answer here. Now let's move to the next question of year 2015. Now in this question, again the similar type of question where the thermal decomposition of ammonium dichromate is given, and it produces nitrogen, water vapor and chromic oxide. Now here there are 4 parts of question, so it's 4 marks. It's in 2015. Now the pattern has changed. We are getting in section B the question, all the subparts either 2 marks or 3 marks. So it is the old pattern where we used to get 4-mark question, 5-mark question with 4 parts or 5 parts or 3 parts subparts. So let's solve this question now. The first part, they're asking quantity in moles of ammonium dichromate if 63 gram of ammonium dichromate is heated. So that is the very direct question. The mass of the reactant, which is ammonium dichromate, is given, and we have to find out the moles. So as you know, the formula of the moles is what is the mass of ammonium dichromate upon the RMM of ammonium dichromate. So we need to first calculate the RMM of ammonium dichromate, which is you can calculate, so 2 times of 14 plus 1 into 4 plus chromium mass 2 times 52 plus 7 times of oxygen. So all these masses will be given here, so no need to memorize any mass. So that way you will get the answer here, total 252 gram. So RMM is given 252 gram. Now the mass they're asking in 63, so 63 divided by 252 gram, and then we'll divide the mass by the molar mass, and we'll get the answer here 0.25 moles. So this I got the first answer, and you will get 1 mark for this correct answer. With the formula you will write, you will substitute the value and answer you will write. Second question is the quantity in moles of nitrogen formed. So now it is relating a reactant to the product. So we have to refer to the balanced equation again, and then we have to see the ammonium dichromate mole ratio to the moles of nitrogen. So if you look at the balanced equation, 1 mole of this produces 1 mole of nitrogen gas. But in the question we have 63 gram of ammonium dichromate, and they're asking the moles, and we have converted already that 63 gram into the moles in the first part. So I can say here 0.25 mole will produce X, cross multiply, so X you will get 0.05 into 1 upon 1, which is equal to 0.25 mole. So my answer is nitrogen produced will be 0.25 moles of nitrogen gas. So this is again 1 mark is done. Let's move to the third part. Now third part they are asking volume in liters of oxygen gas. Now we know the moles of nitrogen gas, okay? So to calculate the volume, as you know the moles formula, the given volume upon the molar volume. So given volume is, we have to calculate, the moles we know 0.25 and the molar volume is 22.4 liter. So each mole of gas or 1 mole of gas occupies always 22.4 liter of gas. So we can multiply by the mole and we can get the answer. You multiply, you will get 5.6 liter of N2 gas. This is again a 1 mark question here. So you can just apply the formula and substitute the values and you will get an answer. Let's look at the fourth part of this question. The mass in grams of the chromic oxide which is forming. So now we have to look at the ratio between the reactant to this product. So as you can see in the equation, again same the mole ratio we have to compare, which is ammonium dichromate to chromic oxide, which is 1 mole produces 1 mole. And the question, they are asking the mass of which is produced, and the mass of ammonium dichromate is taken as 63 gram. And they are asking how many grams of chromic oxide is produced. So we have already calculated the mass of ammonium dichromate of 1 mole. So 1 mole mass is, when we calculated previously, you can see here we got 252 gram. So 252 gram in my balanced equation produces what mass of chromium oxide? You can calculate here the RMM of chromium oxide separately. That answer you will get it 152 gram. So 252 gram produces 152 gram. So 63 gram will produce how much? So again, this is the same way you can write, when you can write down in a statement way that 252 gram of ammonium dichromate produces 152 gram of chromium oxide. So 63 gram of chromium dioxide produces how much grams? So that will be 152 divided by 252 into 63. When you solve this one, you will get an answer 38 gram. So I have taken the mass and compared. You can do with the moles also. Once you find out the moles of chromic oxide, you can convert into the mass of chromic oxide. So that is also the way. It's up to you. You can choose the any way which you find it comfortable and confident during the examination. So these are all the 4 parts. We have completed it. I hope you all have understood the way we are solving the questions here for the past around 10 years question. Thank you, students. I hope you liked the video. Please like, subscribe and share with your friends. Thank you for watching.